Now the question is, find the trigonometric Fourier series of the following signal. The signal is given, that is x of t. Now I will tell you the steps to find out the trigonometric Fourier series. First step, you have to write that the signal x of t satisfies the Dirichlet condition. X of t satisfies Dirichlet conditions. So trigonometric Fourier series exist. So this is the important statement. You know all the Dirichlet condition because the signal is integrable for one complete period. Finite number of discontinuities, finite number of the minimas and the maximas are there. So therefore it satisfies. So trigonometric Fourier series exist. The second step is very important. You find out the time period because that we require. That is a one positive and the negative cycle is constitute the one that is a time period. So total time period from this 0 to this for one complete cycle, that t is equal to, it is 2. From this you can calculate the omega 0. We require that omega 0 is equal to 2 pi f. So this is equal to 2 pi divided by the capital T, and this is equal to 2 pi divided by t, and this is 2 pi divided by t is equal to 2. So equal to 2 pi divided by 2. So this is equal to the pi. So second step is to calculate the omega 0 because that we require. Now the third step, you apply the symmetry properties. As I told you, first you check whether the signal is even or odd. So I told you the signal is said to be even when x of t is equal to x of minus t. So just by looking at the signal, so this signal, if you just fold the signal to the vertical axis, so both x of t and the x of minus t, so it will be same. It will not be same. So if you see, so x of t if is equal to x of minus t, okay. So accordingly, if you look here, the signal is, it is like this. This is the x of t, okay. So this is x of t. Now I want to plot the x of minus t. So x of minus t is just to fold the signal. So if we fold the signal, so this signal will look like this, okay. So it is like this. So x of t and x of minus t are not same. That means that the signal is not even signal. And next, the signal is odd signal. The signal is said to be odd signal when x of t is equal to minus x of minus t. The signal is said to be odd signal. So this is the x of t. If we plot x of minus t will look like this, okay. It is x of minus t. So this is also, sorry, it is x of t, then x of minus t. So just to fold to the vertical axis, the signal will look like this. So x of t and x of minus t are not same. Then you do the minus x of minus t. So the amplitude is multiplied by 1. So if you multiply this amplitude by the minus 1, so it will become negative, that the signal, it will, so this is minus x of minus t. So therefore x of t is equal to minus x of minus t. It means that the signal is odd. So you can write the signal x of t is the odd function. If the signal is odd function, so the odd function, the Bn coefficient is associated with that. So therefore you can write the signal is odd. Therefore the trigonometric Fourier coefficient Bn is equal to 0. There is no need to calculate about the Bn. That is third step. The fourth step is to find out the DC values, that is the A0. I told you if there is an equal positive and the negative half cycle for the one complete period, then the coefficient A0 is always 0. So accordingly, if you look, this is the positive half cycle for 0 to 1, for 1 to 2, it is a negative half cycle. There is an equal positive and the negative half cycle. So therefore always DC value is 0. So therefore you can write the DC value, that is A0 coefficient is equal to 0. The next thing is you need to calculate about only the remaining coefficient, that is equal to the fifth step. You can calculate that the an is equal to what? So just you have to use the formula for the an, and you can calculate the an coefficient, and we will substitute the values of a0, an and the bn into the trigonometric coefficient formula, and we will calculate the trigonometric Fourier coefficient. Now we will go for the an. The next step is to find out the values of the an, and to find out the values of the an, you need to represent the signal for one complete period, that for the t, in terms of mathematical equation, that is the x of t, that is important. So you can write the x of t is equal to, because x of t for one period, it constitutes from the 0 to 2. So the 0 to 1, the value of the signal is 1. So you can write x of t is equal to 1 for t is greater than or equal to 0 and it is less than 1. And for remaining period, because t is 1 to 2, so this is equal to minus 1. For t is greater than the 1 and the less than or equal to greater than or equal to 2 and less than 2. So this is called as the mathematical equation. Now the next step is to find out the values of the an. We know that you write the formula for the an. So this is equal to 2 upon capital T, limit from t0 to t0 plus capital T, that integration for the one complete period, then x of t, and we know an is a even coefficient and it is associated with the cos term, so x of t into cos n omega 0 t into dt. So this is the formula for the an, and we will find out the an coefficient here, and values of the t already we know, I told you in the last slide, equal to 2. So you can substitute this, and t0 is equal to 2 pi divided by the capital T. So this is equal to 2 pi divided by 2. So this is equal to the pi, and omega 0 you can substitute equal to the pi, and t is substitute equal to 2 by 2, that will get cancelled. So this is equal to limit for the one complete period, so that goes from 0 to 2. So there are the two values, one is the plus 1, another is a minus 1. So here the integration consists of the two limits, that from the 0 to 1 and another is from the 1 to 2. So just I will write here, it is a 0 to 1. The amplitude of the signal 0 to 1 is a 1. So x of t is equal to 1. So only it will consist of the cos n omega 0 t. So I will write cos, and omega 0 is a pi. There is a pi n t into dt, plus for 1 to 2 the amplitude is a minus 1. So the limit will be from 1 to 2. X of t is a minus 1. So I will write here the minus 1 into cos of n omega 0 is a pi. So again it will be the pi nt into the dt. So now this is the an. We have to solve this integration, and from that we will get the values of an. We have represented the signal x of t for the one complete period in terms of mathematical equation like this, and we have seen that the signal is odd. Therefore only the bn coefficient will present and the an coefficient will be 0. Now we will calculate the bn coefficient. So the bn coefficient is equal to, you know the formula, 2 upon capital T, that 0 t0 to t0 plus capital T into x of t into the sine of n omega 0 t into dt. So now you can substitute. So the capital T is equal to 2. So 2 divided by 2, that is equal to 1. And the integration will be from the 0 to 2. So I will write, so this will be the 0 to 2. X of t, value of x of t is 1 for 0 to 1 and minus 1 from the 1 to 2. So that I will substitute, and the omega 0 is equal to pi. So it is a sine the pi nt into dt. So this I can write that 0 to for one complete period, that 0 to 2. So the value is different. So you can split this integration into two terms. One is from the 0 to 1 and its amplitude is 1. So x of t is 1. So it will be only your the sine pi nt into dt. Then for the 1 to 2, the amplitude is minus 1. So it will become minus 1. So minus I will take. Then 1 to 2 and sine n omega 0 t, again it will be the sine the pi nt into the dt. Now you solve, we know that the integration of the sine is the minus cos. So this is equal to minus cos pi nt divided by the derivative of pi and t, that with respect to t. So this is equal to your the pi n, and the limit will be from 0 to 1. So again you solve this integration of sine is again the minus cos, minus minus will become the plus, and it will be the cos pi n t divided by differentiation of this with respect to t is again the pi n, and limit will be from 1 to 2. Now you apply the limit so that you will get the values of the bn. 1 upon pi n is common. I have taken 1 upon pi n common. So this is equal to 1 upon pi n. Upper limit is 1, that you put the values of the t is equal to 1. So minus cos the pi n minus lower limit. Okay, minus I will take, minus minus it will become plus, and the cos 0. So this is equal to cos 0 plus upper limit again the cos 2 pi n minus lower limit that 1, that is the cos the pi n. Okay, so if you look at, there are the 2 cos pi n, so this is equal to 1 upon pi n minus 2 cos pi n, this minus cos pi n and this cos pi n, plus the cos of 0 plus cos of the 2 pi n. So if you look at the values for this cos 0 is 1, and cos of 2 pi n, cos of 2 pi n, so that is a minus 1. So 1 and minus 1 it will become, so cos 0 is 1, sorry, its value is 1 and its value is also 1. So this is equal to 1 upon pi n into minus 2 cos pi n plus 1 again plus 1. Cos 2 pi n is 1 and cos 0 is 1. Already I have shown you the table. So this is equal to 1 upon pi n. Okay, 1 plus 1 is 2 minus 2 cos pi n, and we know that the cos pi n is equal to minus 1 raised to 1, since cos pi n is equal to minus 1 raised to n. So you can substitute the values. 2 I will take it common, that is 2 upon pi n. Okay, then 2 I have taken 1, that is minus, and cos pi n is minus 1 raised to n. Okay, and this is our this is our bn coefficient, and we know if the signal exhibits the half wave symmetry, only odd harmonics are present. So this signal will be present for odd harmonics, so that I will just demonstrate you here. Okay, now I will go further in detail about this bn coefficient. Okay, for n is equal to odd. Okay, for n is equal to odd, so when n is odd, okay, minus 1 raised to 1 is minus 1, minus 1 raised to 3 is again minus 1, minus 1 raised to 5 again the minus 1. So this, the bn is equal to 2 upon pi n, and here the 1 minus 1 raised to 1 is a minus, so this minus and minus will become plus 1. Okay, so this bn is equal to 4 upon the pi n when n is equal to odd, when n is equal to e1. So when minus 1 raised to 2, minus 1 raised to 2 means minus 1 into minus 1, so that is a plus 1. So 1 minus 1 it will become 0, so bn is equal to 0, bn is equal to 0. Now we have computed the values for a0, we have computed the values for an, we have computed the values for the bn. Now you write the formula for the trigonometric Fourier series, and that you can represent x of t in terms of the sine and cos. Now let us see, we have seen here the a0 is equal to 0, then an is equal to 0, then the bn is equal to 4 upon the pi n for n is equal to e1, and this is equal to 0 for n is equal to odd. Now the next last step is write the trigonometric Fourier series formula. Okay, we know that x of t is equal to a0 plus summation n is equal to 1 to infinity. So an cos of n omega 0 t plus summation n is equal to 1 to infinity bn sin n omega 0 t. Okay, we know the values of the a0 is 0, that so this is zeros, so the an is also 0, only the bn term exists, and bn is equal to, again that also exists for the n is equal to e1. So we can write for the trigonometric Fourier series as x of t is equal to summation n is equal to 1 to infinity, and bn is the 4 upon the pi n for only n is equal to odd, that I will write into the sin n omega 0. Omega 0 we have seen that is a pi, that the pi n t, and that is for n is equal to odd values. So if you expand this bracket, x of t is equal to, so 4 upon pi, I will take it outside because there is no n concern with this. So I will write the summation n is equal to 1 to infinity, then 1 upon n into sine of the pi n t for n is equal to odd. Now you substitute the values of the n, so x of t is equal to 4 upon pi, for n is equal to 1 it is sine pi t, for n is equal to 3 plus 1 upon 3 into sine 3 pi t, plus n is equal to 5 1 upon 5 sine 5 pi t plus so on. So this equation represents the trigonometric Fourier series. So if you look at this equation, we have represented x of t in terms of sinusoidal component with the fundamental and harmonic frequencies, means the square wave, so which the signal is represented. This is a signal in the time domain, this is t, this is x of t. So this signal can be reconstructed with the help of only the sinusoidal component, that is a sine and the cos. So therefore x of t, this signal can be represented. So if you write a code in MATLAB or any programming language that which consists of the sine terms of these values, that x of t is equal to 4 upon pi sine pi t plus 1 upon 3 sine 3 pi t plus 1 upon 5 sine 5 pi t plus and so on. So exactly you can reconstruct such kind of the signal, and this is called as the trigonometric Fourier series. So accordingly you can solve any kind of the problem for the trigonometric Fourier series.